Okay, good morning, everyone. We're going to start. I see there's a few attendees already. People are joining. So first of all, welcome to everyone. Thank you for joining us today. The session, I just want to give you a few notes on how the session is going to work. The session today will be recorded and the link will be disseminated after today's session together with the presentations. They will all be sent out to the registered participants. We will also be sending the ones from last week on textiles. This is the second session of the webinar series of In Plastics, Understanding the Circular Economy for Chemicals in Plastics. Today's session will be on bioplastics. So today's series will consist of a welcome speech by Magali Auteurs, followed by 4 presentations. Each one of them will have a Q&A session. You can write your questions in the box below. You can see Q&A. We will take those questions after each speaker. If you have any other comments you want to make, you have the chat. And yes, any questions or feedback and comments that you have can be addressed to my email address, which we'll be sharing later. We will listen carefully to any of your comments. If you haven't done so yet, please make sure to follow us on social media. I will provide the links in the chat. And most importantly, don't forget to register for the next upcoming webinars that we're going to be doing. So let me introduce you to Magali Auteurs, who's the policy area team leader at SCP RAC, which is now MedWaves. Please, Magali, over to you.
Thank you very much, Kim, and welcome everybody. So we are very pleased to be with you today. And well, May is usually a very busy month for all of us. So thank you for taking the time to join into a webinar series that will aim to understand how we can be an active part of the solution to phase out toxic chemicals. We know that this is a very complex topic and not easy to understand. And today we will focus on a very emerging topic, which is bioplastics. And in order to be part of the solution, we believe that we first need to better understand. So that's the aim also of the webinar, is to understand the state of knowledge on a specific topic related to chemicals, and then to take actions. For us, it is crucial to have a multi-stakeholder approach in the sense that we need to engage with policymakers in order for them to be able to better design and enact regulation, to engage with consumer, for them to make informed decision when purchasing items, but also when moving within their network and community. And last but not least, with businesses, for them to increase transparency and operate to reduce the use of toxic constituents in plastic and switch to safer alternatives. So we strongly believe that whether you are a consumer, and we are all consumer, manufacturer, entrepreneurs, also financial actor or policymaker, you have a role to play in that topic. So just a few words about MedWave. So for those that joined us last week, you will notice that we changed them from one week to another. This does not happen every week because this is the end of a 2 years process to change your identity. So last week we were SCP RAC, which was a very complex name, and now we have a name that hopefully will be easier to pronounce and to remind. So we are MedWave, the Regional Activity Center for Sustainable Consumption and Production, but we are the same team behind, and we are still based in Barcelona. And our main mission is to support sustainable consumption and production patterns using a circular economy approach. And we have a strong focus, therefore, on pollution prevention, and with many actions targeting plastics and toxic chemicals, in particular in the Mediterranean region. Since 2009, the center operates in support of the Stockholm Convention, which is international agreements involving 190 countries to fight against the generation of persistent organic pollutants, which are the highly polluting and toxic substances. So in this context, we have specific action again on the prevention side. But the center also is a regional center of a regional convention, specifically targeting the Mediterranean. So we are a regional center established in the framework of the UNEP Mediterranean Action Plan. That is the program of the UN Environment established to support the member countries of the Barcelona Convention for the protection of the marine environment and coastal region in the Mediterranean. So it is in this conjunction of mandates, so between a global mandate on chemicals and a regional one that is focusing on the Mediterranean, that we find the opportunity to develop a project that can combine both mandates. So we want to shed the light on the impact of toxic chemicals on the life cycle management of plastics. In the Mediterranean, we know while the plastic pollution is a very, very serious it's a very serious issue. The Mediterranean region, the sea, has the highest concentration of plastic debris, and at the same time, the Mediterranean is a hotspot for biodiversity. So we talk a lot about the issue of microplastics, but we need also to address the issue of additives, because they constitute the invisible part of the plastic pollution issue. But they are also having, we are seeing now that they are having a serious impact on human health and the environment, and in particular the marine environment. So the webinar of today, just to close, is implementing in the framework of the small grant program to tackle plastic waste, managed by the Basel, Stockholm, and Rotterdam Secretariat of those convention. And it is aiming to assist countries to improve their management of plastic waste, and ultimately to contribute to SDG, and in particular the SDG 14 for oceans, with the specific goal to prevent and significantly reduce marine production of all kinds, in particular from land-based activities. So I will stop here for now. So let's dive into the topic of bioplastics, and I will give back the floor to Kim, that will present our distinguished speaker for today. Thank you very much.
Thank you so much, Magali. Just to let everyone know, I've made a mistake on copying the links to our social media. I'm still in the past, and I have just posted the new website. I invite you all to look at it and enjoy it. It's really fresh and new, and we are really excited about all the content that's on there. So yeah, let me briefly set the scene for today. So bioplastics, single-use plastic packaging is being banned across the world, and manufacturers and consumers are turning to alternative materials such as bioplastics and plant-based materials. But what we're going to be addressing today is, are bioplastics and plant-based materials safer than conventional plastics? And how much do we know about chemicals and what they contain? And are the safety of these compounds? Can bioplastics play a meaningful role in improving the sustainability of the chemical industry? So I'm going to launch a poll for everyone to warm up, and there we go. If you can click on the answers, I hope you can see it. Okay, we have a few people answering already. I don't know if people can see it. Paul, can you confirm that this is visible to everyone? Or yes? Okay. I am told that there's an option to launch this, but I cannot see the button where the results can be shared. Let me just see. First question is, how are you feeling this morning? Are you ready to start or needing some extra coffee to wake up? Second question is, which region are you from? Which type of stakeholder are you? Okay. I think we have a few people answering already. So I'm going to share the results. Here we have a lot of people ready to start. That's good. We have a few people from the Western Europe, Mediterranean as well, from America. Which type of stakeholder? We have quite a few independent consultants, NGOs, entrepreneurs, policymakers, students, academia, public administration. Lovely. I was told last time, consumers, we're all consumers in the end, so we can all put ourselves in that category. After that, we have a couple of questions which were a bit more tricky. So bioplastics are always degradable and safe for the environment. Natural, so they don't contain chemical additives. Nope. Regulated just like the rest of plastics. Always recycled like fossil-based plastics. And plastic materials produced from renewable biomass sources. So I am going to have to tell you, we're going to learn more about this. The only answer was correct was the last one. And the fifth question was, which of these sentences are true? Everything that is compostable is biodegradable. Biodegradable plastics can also be synthesized from fossil fuels. And biodegradability can be an end-of-life pathway only in certain applications. The correct answer was all of the above. So we're going to finish this poll and hear more about it, learn more about it. So our first speaker today is Simon Han. Please, Simon, if you can switch your camera on and share your slides. Also put your microphone on, and I will ask the rest of the speakers if you can please switch your camera off. So Simon works for Eunomia since 2013. He's the life cycle assessment specialist after 7 years working for an internationally recognized UK manufacturer called Mira. Whilst working as an engineer, he has developed an extensive knowledge base of materials and processes while studying for an MSc in sustainable product design. His thesis, which looked at how LCA can be integrated into the design process, was awarded as a distinction, and the tools and models developed as an output continue to be used by Kohler. Okay, over to you, Simon. Thank you so much.
Thanks, Kim, and good morning, everyone. So yeah, I'm a consultant for Eunomia Research and Consulting, a UK consultant, and I'm here to set the scene today, I think, for the subject of bioplastic, and give you a very I guess brief overview of some of the main issues in the 20 minutes that I've got. Obviously very complex subject, so I'm going to go over quite a lot of things, but hopefully it will set the scene quite nicely for you. My background work that has contributed to this has largely been for the European Commission over the last few years, working on subjects like microplastics, biobased and compostable plastics, understanding their limitations and the impact they have. So this is the sort of culmination of a lot of that work over the last 5 or 6 years. So I'm going to jump straight in now and give you a bit of a definitional lesson initially, because there's a lot of confusion around the way in which we talk around bioplastics. I tend not to use the word bioplastic anyway, because it doesn't always, it can be quite confusing for people. So the two important terms are biobased and biodegradable, and these tend to be used interchangeably, like the bioplastics are all biodegradable, or all bio-based plastics are biodegradable, so it can be quite confusing. But the term bio-based really only describes the source of the raw material and the feedstock, so where it actually comes from, a biogenic source, either from waste or from crops grown. And the term biodegradable is quite a complex term, but essentially it describes only a material property in itself, the ability to biodegrade, and I'll go on to that a little more later. But the important point is neither confers any sustainability attributes or any environmental performance. Neither of these things are good in and of themselves just because they have these properties or feedstocks. There's a lot more to it, and I'll go into that in a little more detail. So moving on from this to go into a little more detail around the definitions. So not all bio-based plastics are compostable or biodegradable, as I just said, and you can see in this diagram on the right here, which has been reproduced in different ways from different people over the last few years, and it's quite a good way of showing that there's these 4 quadrants essentially around whether they're bio-based, fossil-based, non-biodegradable or biodegradable. And you can see that there's an overlap in that top right corner where you can be bio-based and biodegradable, but equally you can have biodegradable plastics that are fossil-based. So they can biodegrade in certain circumstances, but come from a fossil origin. So as you can see, it doesn't matter what the feedstock is of the material necessarily. In order for it to be biodegradable, you can have those materials. And equally in the top left corner there, you can have bio-based materials that aren't biodegradable. They are just very much the same as common conventional plastics in reality. So, and it's important to recognize that bio-based and biodegradable plastics are still plastics in their own right. They're still polymers, they're still plastics, and whether they should be treated in the same way largely depends on their properties and where they'll actually go at the end of life. So I'm going to start talking about issues around biodegradable plastic, and then move on to issues around bio-based plastics themselves. So I'm going to deal with them one after the other. So biodegradable plastic in itself, biodegradable isn't really a helpful term because it doesn't really define where the biodegradation happens. And that's really the key part of this, is that a material isn't biodegradable unless you can say which environment you're talking about and make sure it stays in that environment. And you'll see from left to right here that different environments have different levels of, shall we say, aggressiveness to biodegrade in a quicker time frame. And so all the way on the left there, you've got landfill, marine water and fresh water. So particularly there's a lot of talk about things being able to be biodegradable in the sea and the oceans to reduce plastic pollution that ends up there. But unfortunately, at the moment, there's no real common set of standards that allow us to assess that and say, this can go into the sea and it will be fine. And one of the main issues with that is the marine environment isn't just one environment, it's many environments. It could be the surface of the Mediterranean in summer at 20 or 30 degrees, or it could be down in the deep sea where it's sub-zero. And so, or it could be anywhere in between. So it's really hard to create a standard that we can recognize globally, that to say that none of this material can go in the sea and it can cause no impact whatsoever. So that's a major problem at the moment, and one of the issues I think is going to be ongoing, because do we really want to use the sea as our dumping ground, even if it only lasts a couple of years? What's potentially more interesting is the managed aspect of biodegradable plastics. So where we can control the biodegradation process to allow it to happen, and we can put the materials in there specifically. So soil is one which sort of crosses over between the two, and there's one product that it has a standard associated with it, and that's agricultural mulch films. A very specific application for agriculture, so I won't go into that in more detail, but suffice to say, if you can't really just have a product that you can just drop on the soil and will biodegrade within weeks or months. It has to be for a specific application in agriculture. Home composting is another sort of semi-managed process, and I'll speak a little bit about that later. But anaerobic digestion and industrial composting are the two main focuses of standardization at the moment. And you can buy products on the market right now that are certified to EN 13432 in Europe, and that is designed to allow you to test to that standard and certify it so that it can go through composting. And I'll speak a little bit about why that isn't necessarily the case in reality. But as you can see, there's a continuum here and it's not just one thing. And it's always important to say, well, what is the environment we expect it to go into? Is there a standard available for us to test to? And is it even right to try and do this in the first place, bearing in mind that biodegradation, once it goes, it's gone, and there's no way of getting that value back into the circular economy either. So very quickly on the sort of typical composting conditions here, you can see from left to right, again, you can see why they're more aggressive on the right, because it's all about temperature and the availability of bacteria and fungi. So all the way in industrial composting there, it's high temperature, kills the bacteria, but allows kills the bacteria that's harmful, but allows the bacteria that feeds on the waste and the plastic to thrive. And these are the main processes that you'll see. And so the question is, why is all this important? Well, this is what we often see coming into and potentially out of composting, even throughout Europe. And plastic waste going through bio-waste treatment is a major issue for any bio-waste collection. And the key question is will biodegradable and compostable plastics, do they contribute to this, or do they help with this issue? And that's part of what we had to explore with the European Commission over the last few years, is to what extent does putting biodegradable plastics through the composting system, does that encourage other people to put other plastics in there? Is there confusion around what you can put in there? One plastic bag made out of compostable plastic next to one that isn't and is made out of polyethylene can look very similar and can confuse people. So it's a very important issue to reduce plastic in compost that inevitably will end up on the soil, and can biodegradable plastics help with that? So looking at the sort of bio-waste treatment that we get in Europe, and you can see there's a few example countries here about with the two major bio-waste treatment types here, anaerobic digestion and industrial composting. And you can see from the UK that putting these materials through AD is generally not a good idea, because we have what we call a wet AD system, where it's a slurry that's pumped through pipes. And that's a big problem when you've got plastic in there and it gets caught up and doesn't actually biodegrade in the end. France it can be problematic for some of these materials. Germany is generally against having any biodegradable plastics in their bio-waste treatment. Italy is one of the few countries in Europe that has embraced compostable plastics. They have a system set up for it. It works really well, and their bio-waste treatment system is very much set up to work with these materials. Belgium and Spain, again, somewhere in the middle, and can be problematic. So, and this is the major problem we have at the moment, because we have a set standard in Europe, but all the countries operate differently. So you can't actually guarantee that if your product is certified to EN 13432 and put it on the European market, that it will end up biodegrading in the way you hope it will in a composting facility. It's absolutely not guaranteed. And so this is why this standard is currently in the process of being updated to help counter the issue that countries operate in different ways, and that their bio-waste treatment systems all operate in different ways as well. And so home composting is also an interesting one, because a lot of companies are trying to produce home compostable materials and bags and pouches. But that's also an issue, because we just don't know 100% what will happen to that, because that's very much down to the individual and the way they run their home composting. You can run it very well, or you can run it very badly, and that can happen across the board in any country. So it's a very tricky one to deal with, because how many plastic bags do you really want in your home compost? What's the tipping point between, by the point you get, you know, more plastic in your home compost than actual bio waste? So if all the companies who wanted to put these sort of plastics in your home compost could do so, it would get to the point where is it really a waste treatment, plastic waste treatment option? Is that where we want to get rid of our plastic in people's home composting? And not least because it's not actually available to everyone as well, particularly in cities. So it's a tricky one. So one of the ways we looked at this was we suggested that the focus should be therefore on the use of compostable plastics that have proven added benefits. So do they increase the collection of organic waste and the diversion from residual waste? So does the product itself help to take organic waste out of landfill? Because that's one of the major problems at the moment. And does it reduce plastic contamination of compost in general? Does the actual product help to reduce confusion and increase the amount of healthy compost we have? So, you know, a good example of this is a bio-waste bag that you collect your organic waste in. And so that reduces, if they're handed out to all the residents, then that reduces the different kind of plastics that might end up there, increases the participation of collection of organic waste and really helps move that forward. So that's a good example of a beneficial product that has added benefits. I mean, and all the way on the other end, maybe you don't want to be making plastic bottles, beverage bottles out of compostable plastic because they look almost identical to your standard PET bottle. They don't add any benefit to the actual compost itself. It can create confusion, and we have good recycling of PET anyway, so why would we need to do that? So that's the way to look at it. I think it's not a straightforward thing to look at, but there's definitely some products that would benefit from it, but it's not something that we should be moving wholesale through to. So that was a very quick overview on biodegradable and compostable plastics, and I'll move now on to bio-based plastics. So obviously any of these compostable plastics that I was talking about could be made from bio-based material. The focus here, though, is on bio-based plastic that is not biodegradable, so is a substitute for all of our plastic that we use in our lives at the moment. And there's two broad categories that we have. One is drop-in bio-based plastic, which is chemically identical to existing conventional plastics. So you've got sort of bio-based polyamides, nylons, polyethylenes, PETs, polypropylenes. So all the same materials we're familiar with, but they are made from a biogenic source. The other one is novel bio-based plastics, and these are unique and only made from bio-based feedstocks, so they're very specific. There's no alternatives that are made from a fossil-based option, and PLA, PHAs, PEFs, a lot of acronyms here, and starch blends are typical ones that are increasingly on the market at the moment. And so this is important because the benefit of the drop-in plastics is they can be direct replacement with no processing changes. So you can switch them out. They can go through the same injection molding process or blow molding process that they are. You wouldn't be able to tell the difference in the way that they're processed at all. They're chemically identical. And that also means that they work within existing recycling systems. So if PET, for example, being recycled quite well, then bio-based PET will slot straight in there very well indeed. But obviously there's a trade-off for these. There's never a straightforward story. So one of the issues with these drop-in plastics is they can be inefficient use of input biomass, which I'll talk about in the next slide. And also some polymers can't be 100% bio-based, or they can't as yet, or even have a bio-based alternative at all. So a lot of very technical polymers that are used for very specialist applications don't have a bio-based alternative at the moment. For novel bio-based plastics, they may provide a unique properties that improve functionality. So sometimes they actually do the same job as the drop-in version, but actually do it better, have better properties. So are actually functionally a better choice. And the benefit also is that they often have increased use, more efficient use of input biomass. So that's their main benefit compared to the drop-in, is that the biomass, you use less biomass to produce that. But then, of course, the downside is recycling is very limited at present, and that's partly because there is so few on the market, and the tonnages are low, and therefore there's no incentive for recyclers to pick these materials out and try and recycle them. And so essentially you've got this trade-off. Do you go for efficiency of biomass, or do you go for putting the same materials on the market that can fit in the existing recycling systems? So as I mentioned, feedstock efficiency is a very important part of this part of the picture. And as you can see, it varies hugely between polymers there. So polyolefins and nylons are particularly challenging to efficiently produce from bio-based feedstocks. You'll see there only 20 to 23% of the material efficient. Only 20 to 23% of the material is efficiently produced from say a ton of in this case sugarcane. So that's a problem. Compare that to PLA, where essentially you need 3, 4 times more land to produce these materials. And yeah, as we see there, PLA at the top there is the most efficient, but then that trade-off of lack of recycling is a problem. And we'll see there as well, 100% bio-PET is challenging to produce at the moment. It is technically possible, but there's very little on the market. It's not something that you can get very readily available. So at the moment, most PET bottle producers have to rely on just this 30% bio-MEG PET, which is quite efficient, but also only a 30% bio-based content. The next issue here is land use efficiency. There's lots and lots you could talk about around land use and our transition to bio-based plastics and how that fits in with food crops. One thing I would say on that is, if we simultaneously move more towards a plant-based diet, then that would make a massive difference in the land availability for bio-based plastics as well, because if we're not feeding crops to animals to then feed to ourselves, we can reduce the amount of land massively, and therefore the land can be available. So there's a lot of interlinkages between our food chain in this as well. But it's notable that bio-based feedstocks can come from several different crops, but with different levels of efficiency. You can see there right at the top there, wheat is the least efficient by quite some way, and the sugar cane and sugar beet are the most efficient. But it's worth bearing in mind that this one metric doesn't always determine the feedstock with the least impact. So it might have a lower amount of land. Sugarcane, for example, might have a lower amount of land, but where does it come from? And there might be some issues with that, either social or environmental, with the way sugarcane is produced. And that's an important part of choosing your materials, understanding the feedstock and where it comes from, and making sure it's sustainably done. Sugar beet can be produced in Europe, but at the moment the price of European sugar beet has driven supply of sugar from cane from Asia. So yeah, there is definitely a lot of potential in the future to be producing these materials locally rather than relying on international supply chains, and as we do at the moment with fossil fuels, getting them from countries outside of Europe, which we don't really have much control over. the supply, and obviously geopolitical issues at the moment is a massive red flag for making sure we have access to materials. But in the global north, we could easily grow sugar beet, and in the global south, they could grow sugarcane as well. So it's about having the right feedstock in the right place, and having a good value chain for that, which is very different to what we have at the moment. One of the final issues I want to talk about is biomass balance. So this is a very complex and intricate subject, and hopefully I can do it justice in a minute or so here. But essentially, there's a relatively new way of introducing biomass into polymers, mainly aimed at polyethylene. And this basically involves using waste cooking oils, animal fats, and wood residues. So worth bearing in mind that anyone who's on a vegetarian or vegan diet, this is a bit of a red flag that you might end up having polymers that are made from actual animal products. So that's an interesting move there potentially. What this does is actually creates bio-naphtha, which is a feedstock for the petrochemical industry to go into steam crackers. So they use naphtha that go into steam crackers that produce ethylene. And what they can do is they can feed bio-naphtha in with fossil naphtha into this system, and then produce the material out the other end. But the issue with this is that it decouples the physical connection between the inputs and outputs. So with the other bio-based plastics, you start with a material with a bio-based crop with sugar, it gets fermented, and you end up with some chemicals that get produced. It's a linear chain, and right at the end you can say this is a bio-based material. You can even check it using carbon analysis, C14 analysis. But with biomass balance, you're putting it all into a big pot, and you're getting lots of materials out, and you don't know whether this material at the end has much bio-based content in it or not. All you know is what you put in. So you can see there in a diagram, you put 10 units in, and your actual output there might be 10% bio-based content. But what you might sell is 100% bio-based content of those 10 units. And there's an example there of how that's been advertised at the moment, saying, it's wrapped in 100% plant-based packaging. So there's an interesting conversation around how that is being marketed and how that's being conveyed, because it's very possible that packaging might have 0% plant-based content in reality, but somewhere on the market there is that amount of plastic that is bio-based in somewhere else. It's just spread out. So yeah, it's a different mindset. It's a confusing way of communicating, and consumers probably don't really understand it. But one of the things is it's important to have a strict chain of custody to make sure it's traceable. So final slide in this sort of very quick overview, talking about bio-based plastics contributing to net zero. So that I think there has to be a transition towards bio-based plastics from fossil plastics. If we understand that we definitely need to use certain plastics into the future, and we also definitely need to move to net zero and to reduce our reliance on fossil fuels, it's important to do this. And you can see here from this graph, this is the annual global GHG emissions from the whole of the plastics industry. So just over sort of 2 gigatons of CO2 equivalent per year. And if we assume a 2% annual growth in plastics, which actually is quite a conservative, some people are even saying double that, but that means by 2050 we're producing twice as many plastics as we are now, and it could be up to 4 times as many. But what we can see here is up in the top right, our transition to net zero is very contingent on having key things like bio-based plastic, and a move to, in this case, sugarcane as an example, shows that reduces that gap to net zero a little bit. I put that in context with reducing to low carbon electricity as well, but we'll notice there's still a gap there. that bottom arrow there, saying, well, that's our gap between where we might be and where net zero is. And so that has to be a gap filled with either consumption reduction probably and an increase in circularity. So we need to be recycling a lot more and getting these materials in the circular economy. So bio-based plastic is going to be key to that, but there's obviously a lot to figure out between now and then. So finally, some takeaways on this. So bioplastics are not inherently good or bad. The name of this presentation was I guess a little bit yeah, just putting a question out there that is really quite easy to answer in the end, because yeah, they're not that good or bad inherently, but you need to think about where they come from and the applications they're used in. So, and biodegradable and compostable plastics, not a wholesale solution to plastic pollution. Don't make all of your materials out of that. It's going to be a bad idea, but pick and choose the right applications. Choosing the right bio-based feedstock is challenging due to various options, which might not all be sustainable. So it's not like you do today, where you just pick a polymer off the shelf and they're all basically more or less the same. They'll all have their different value chains. They'll all have their different feedstocks, and understanding that is going to be very important in the future. And land use is very important, but it doesn't tell the whole story. There's a lot more depth there. Biomass balance plastics provide another option, but again, nothing is without trade-offs. And finally, the transition to bio-based plastics will be a key part of reaching net zero, but obviously taking into account of all of those points above as well. It's going to be an interesting journey, but a necessary one in the future. So that's my very quick overview of all of these very complex subjects. So happy to take any questions if there's still time.
Thank you so much, Simon. That was super insightful, really interesting. Clearly, yes, my main takeaway here is clearly there's a lot to learn as a consumer, and to make an informed decision on what we purchase is going to be challenging, especially for people who maybe do not work in this sector and have no insights into this. So yeah, communication is key, which is what we're doing here today, hopefully shedding some light on the topic. So let's there's a few questions from the audience. We have a first question from Roland Weber. He asks, the starch-based plastic seems nicely degradable. How is their performance as plastic product, and for what products they can be used?
Yeah, so yeah, the starch-based are materials that have been around for many years, and that they are generally sort of ready degradable. The issue is they can't, they have difficulty being used in more in say rigid applications. They have to be blended with other materials like PLA as well. So biodegradable plastics tend to be blends of different polymers to try and get the properties you want. So it's not as easy as, oh, we'll just make everything out of starch and it'll be biodegradable and they'll work really well. There are always trade-offs with the actual functionality, and so yeah, it's a tricky one, that, but yeah, it is quite a common polymer to use in bio-waste bags, for instance. So yeah.
Okay, thank you. We also have a question from Errol Cavus. Good morning, Errol. He says, hello, I wonder if there is agreed standard labeling for bioplastics products today. If not, any work to have a standard labeling on bioplastic products?
So if we're talking about specifically on the bio-based plastics, so the certifying the sustainability of the biomaterial that comes from it, there are several schemes that attempt to do this. So as I alluded to, there's quite a lot of sustainability issues with the value chain, and some of these labels attempt to assess that value chain to make sure that that it's, you know, things like you're not chopping down rainforests to produce sugarcane, you're not exploiting the local people and so on. So there are labels out there that exist. One of the things I've often had to do for companies that I've worked for is explore these labels and standards and certifications to help them understand what exactly they do and how good they are. And it's not an easy thing to do. You can't just pick a standard off a shelf and be very sure that it's achieving everything you need. So yeah, there are labels, there are standards out there, but again, they tend to be quite hard to understand and to be sure that you're getting the right material and it's actually genuinely sustainable, which is that's a moving target in itself at the moment.
Thank you, Simon. Okay, I think we're going to move on to the next presentation now, since we're running a bit behind schedule. So our next speaker coming up is Janine Cordouan. She will be presenting the Bund perspective on sustainability of bioplastics. Please, Janine, if you can unmute yourself and put up your presentation.
Hi, everyone. Good morning. Just starting the presentation now.
Okay, so Janine Cordouan works for the Friends of the Earth in Germany, Bund. She was born in 1986 and studied environmental science and technology. She got the DIN, this is going to be challenging to pronounce, Nachwuchspreis, Young Talent Award of DIN for her master thesis on her contribution to DIN spec. She has worked at Heinrich Böll Foundation as a program manager in the Division of International Environmental Policy. And since 2020, she's a senior program officer for circular economy at Bund. Over to you. Thank you, Janine.
Thank you for having me. I'm happy to being able to present today the B&D perspective on the sustainability of bioplastics. So I'm working as a senior program officer for circular economy at Bund für Umwelt und Naturschutz, Friends of the Earth, Germany. We all know bioplastics, their share on the market is growing. Starch blends, PLA, also fossil PBAT are growing, and polypropylene have really high numbers of growth predicted until 2025. We also know that half of all bioplastics is used for packaging. That is even a higher share than other fossil plastics. So we know that they are used for a lot. They are used a lot for single-use packaging. Bioplastics are not only used for packaging, but also for other products. Like Puma uses bioplastics to produce shoes. Also, a few months ago, they were looking for 500 people testing new shoes for half a year, and then they would want them to be sent back and compost them and do some tests. So this is a very good example of a short-lived products, and it is exactly the opposite of what Bund would find sustainable. We as Bund also see that the term bio is misused, so a neutral discussion is quite difficult. It is very irritating for consumers, as it does not have anything to do with the clear criteria according to the EU regulation on food. We as Bund expect also that especially bio packaging will be littered a lot, and even more than we already observe as plastic being littered a lot also in Germany. What is bioplastics? Thanks to Simon, you already know a lot, so I don't have to explain so much more. He also mentioned that most bio-based plastics contains fossil and bio-based parts, and there are also bio-based plastics that are blends of different bio-based plastics mixed with fossil parts. And luckily, he already explained the mass balance approach, so you already know what this is about. So I can only add from a B&D perspective that we demand a clear and communication on the bio-based contents. And if this is not the case, we think that this is a way of greenwashing of packaging. So let's look at the raw materials for bio-based plastics. Where do they come from? They come from Europe, but also from Brazil, for example. So when we use arable land for plastics production, we definitely see that there's a competition about land use. So it's about food production, pasture and fodder cultivation, and also biofuels. They all compete for the same land, and in some cases, land is doubly and triply planted. So this is the new bioeconomy that we are in right now. What we also see as a nature conservation organization, that there is an increasing pressure on extensively used land and also on protected areas. So we see this as a threat for climate and diversity. When we use raw materials as feedstock, it comes with all the negative impacts of industrial agriculture that we know. So there's a high fertilizer input, and especially in Brazil, there is pesticides used that are even forbidden in Europe. And then we also have the problems of soil erosion, water pollution, and the destruction of biodiversity. There's also a risk of increased cultivation of genetically modified plants, for example, corn. When we look to Brazil, where a lot of sugarcane is cultivated, see and observe that that this leads to a wave of conversion of former cattle pastures, so more extensively used land, into intensively used monocultures. So there are few large corporations, which are, by the way, also often not farming corporations or farming companies. It is no small-scale farming at all. And obviously, this leads to serious negative impacts on indigenous peoples, the local environment, and the climate. There's also another indirect important effect. Even though sugarcane is not cultivated in rainforest areas, it still leads to the expansion of cattle ranching in former rainforest areas. So this is a very important indirect effect to consider. When we look at biodegradable plastics, there are different norms that were already mentioned. They don't include a complete degradation. So it only needs to be degraded to 90% of the former material input. They usually need more time to decompose than German composting plants actually operate. So they usually need about 12 weeks, and German composting plants operate about 8 weeks. So you have seen the picture of the plastic that is sorted out, the bioplastic together with the plastic. It's all sorted out manually, which is kind of intense and a lot of work, and then it is burned. Even if if the plastics was composted longer, it does not contain nutrients, so nothing useful that could actually be a good part of a compost in a circular economy. So we as BUND see composting and burning as a disposal of valuable resources. Then this contradicts the circular economy that we should actually thrive for. Let's talk about chemicals. Was also mentioned before. Bioplastics contain various additives that provide all the respective desired properties. There is more than 10,000 different chemicals that have been associated with plastics, as those are the intentionally added substances from the producers. But there's no transparency, so you never know what is actually in which packaging or which plastic. And then there's also non-intentionally edited substances that are created, for example, in the process of production as byproducts. None of these are included in the standards. The 13432 that was mentioned before tolerates, for example, up to 5% of non-degradable additives. So there's no regulation of their persistence, accumulation, or toxicity. when we assume that the 870,000 tons per year of biodegradable plastic that is produced globally contains 1 to 5% of those substances that I just mentioned, we calculate that approximately 9 to 40,000 tons of barely known chemicals are actually released uncontrolled into the environment annually. Let's talk about recycling. It also has been mentioned before. It is only possible for drop-in polymers and not for the new polymers. So they are all sorted out in the recycling plants and they are burned. Chemicals are obviously also a problem for high quality recycling. And there are also limits of recycling that I want to mention here. So there's a high energy demand, and each recycling cycle, we also have material losses. For example, a recent report by Zero Waste Europe showed that most of the recycled PET from bottles is used for products of minor quality and not for bottles. Therefore, as a BOND, we think that only reuse is actually sustainable, so refill and reuse. So we say bioplastics is not really bio. Large-scale industrial production of raw materials for bio-based plastics is not sustainable. Composting and burning is a disposal of valuable resources as it is neither circular economy nor recycling from our point of view. What we need is transparency on the actual bio-based content and also on all the additives. We see recycling has limits. It includes material and energy losses. So from BOND perspective, bioplastic is a false promise for the plastic crisis right now, and only reuse packaging or long-lived products with toxic-free materials are truly sustainable. Thank you very much for listening. And for the German speakers, I can only add that we just published last week a new background paper on bioplastics. I think we will also translate it, but right now it is only available in German. Thank you so much.
Thank you so much, Janine. Super interesting intervention. I do have a question from the audience for you, from Roland Weber. He said there are many areas in Europe which are polluted and cannot be used for agriculture. For example, several floodplain of industrially impacted rivers. Could such areas be used for bio-based plastic, not competing with food? Is there research if contaminants might be transferred or not?
This is a very good question that I actually cannot answer, and I would like to discuss this with, maybe my agricultural colleagues that work on agriculture and look at land use. It's not my competence to answer that, I'm sorry. But I think we should take this question and keep it in mind and discuss it in further discussions.
Sounds good. We also had a question from Andres del Castillo, senior attorney at Ciel. This was directed at Simon, but I'm going to put it out there and see if either you or Simon wants to take it. So the negotiations of a plastic treaty will cover the full life cycle of plastics. From your point of view, where this cycle starts when it comes to biodegradable bioplastics?
Simon, do you want to answer that? Because I think you have also more experience in life cycle assessment. I would say, of course, it should cover the whole life cycle as early as possible. So, but yeah, that's very general. So Simon, I'm happy if you could add anything.
Sure, yeah, I totally agree with that. Yeah, it would have to start from the cultivation of any of the products. So yeah, it would have to begin from the agriculture and everything that goes into that. But also, if you're using waste products, you have to think about where those wastes come from as well. There's definitely some potential trade-offs there where what is a waste product now might become the main product, and it's no longer a waste. It's actually is the main product, and how you look at that from an LCA point of view gets very complex there. But yeah, definitely, if you're looking at the full life cycle, you have to go as early as you can.
Okay, I hope that answered the question for you, Andres. Thank you for joining us today. Next presentation coming up is Peter Bainish. He will be talking about the safer chemicals in plastic by using in vitro toxicity profiling. So here's where we get into the also juicy part of the toxic chemicals issue. So I see you putting your presentation up. Great. Peter Bainish works on in vitro toxicity profiling of emerging pollutants, PFAS, EDCs, POPs, that's persistent organic pollutants for whoever doesn't know, in water, food, plastic, wildlife, and human health. More than 100 international publications and cases about pollutants, dioxins, PCBs, POPs, EDCs, and PFAS, and their impact on the environment, wildlife, and humans. He is the director of biodetection systems in Amsterdam. They work with IPEN since more than 10 years for global egg monitoring and chemical in plastic monitoring. So thank you so much for being here today, Peter. Over to you. You have to unmute your...
I see that. Good morning, everybody. How is this going here? Good morning, everybody. Now we are. So thank you very much for the invitation. I hope you're all awakened, and thank you very much for the first two presentations before me, which explained a lot and also made me a lot of things clear, that also toxicity is very important for those products. Now, we are since 30 years involved in testing of the plastic additives and the plastics. And after being in Tübingen, studying the first endocrine disrupting chemicals, and then going to Japan, being involved in the bioplastic and plastic discussions for the biosales, we are doing this since a long, long time. Now, so today I would like to bring you in this world of toxicity. And my title is Safety of Plastics and their Bioplastic Alternatives. You can see here on the first page that we are involved in a lot of different plastics, of course. And there's an increasing amount of all kinds of pollutants indicated before from Janine also. And so what we are trying to do is to do it with toxicity testing with human cell-based technology to get a grip on those chemicals. Now, my content today will be at first a little bit about the public concern about safety of plastic, the plastics and chemicals of concern, known versus unknown chemicals, as Janine introduced already a little bit. Then I will show some toxicological profiling of plastic additives, and I will finalize with industry innovation and developments and the European Green Deal zero pollution projects, which we are involved to move here forward. Now, you certainly have seen many of those in the last 3 years. As you can see here, plastic chemicals, feminized boys, are plastic baby bottles harmful? And of course, bisphenol A, PFAS, and all those chemicals are in the daily news. So there's certainly concern from the public about these chemicals. One of the issues, of course, that we see more and more of these chemicals involved in the plastic cycle and recycle. And of course, plastic is also paperboard, metal coatings, printing inks, adhesives. So it's a wide range of consumer products which are involved in the discussion. And there's also a wide range of chemicals in that: phthalates, mineral oils, PFAS, endocrine disrupting chemical, EDCs, and so on. And we believe that at the moment, the chemical analysis is only focused on the top of the iceberg with the EAs, but there are many more in the non-intentional added substances, NIAs, as shown before from Janine as well. Now, as you look at the list of these chemicals, they have very different structures, and therefore it's also very difficult to cover those with chemical analysis. So we believe we need umbrella technologies which look at the most important mode of actions to cover that. And if those bioassays have no activities, then we can be sure that the EAs and the NIAs in those complex mixtures are not a risk for human and wildlife health. And the challenge is, of course, here that, it's many chemicals, as I've shown from Janine before, more than 10,000. It's very different plastic materials, and they're used in very different places. And I agree with Janine, there's really a lack of supranational and harmonized regulation. And as Simon told us, it's very complex, the whole supply chain for the plastics. In the last 2-3 years, we are very happy that the international experts wrote a couple of review articles. I just take this one here, impacts of food contact chemicals and human health and consensus status. And there they say very clear that it's very important that there's more toxicity testing, because we have only very minor results of the EIS and the NIAS. The risk assessment of unknown chemical is not possible under the current regulatory approach. We need model-sized tiered approach for screening and prioritization. And it's very important to address the mixture toxicity of these thousands of chemicals, because currently we test only a few by chemical analysis, while such bioassays are not really used in the field. And the endocrine disruption is also getting more and more importance in that respect. With the endocrine disrupting chemicals, there was, of course, at first concern about the biocides, and then this framework was set up here. And here are those test systems, what I will talk about today, are mentioned. So it's about the female hormone, the male hormone, the thyroid hormone, the PAHs and the H receptor agonists, the thyroid. Those are the most typical used bioassay. And there we have also OECD and ISO standards. So for the female hormone, it's called estrogens. We use the AR alpha Calox OECD TG455 approved. For the male hormone, the anti-androgens or androgens, we use the AR Calox OECD TG455 and the H295R steroidogenesis test 456. And for the thyroid hormones is currently in the preparation. So those is the bioassay which I will talk today about, and they're mentioned in this guideline for biocide. And we have, of course, now the situation that we will have a read across from this guideline. How important is this also for plastic additives? Now, I just have some slides how this technology works. So it's high throughput out testing. We have robots who are seeding our human cells. Then we put the cells on the 96 well blade. Then we put the different compounds on that and the unknown mixtures of that. And then we have a high throughput out readout luminometer, it's called, for testing this concentration. So it's really possible to test thousands of samples in a very short period. So the technology is there. The technology is also standardized with ISO and OECD guidelines. And here you see one of the latest 19040 ISO standard. Here we mention many of the plastic additives. You see here on the left side, bisphenol A is a clear endocrine disrupting chemical. Nonylphenol, octaphenol, phthalates are written in here. So it's mentioned in that, and we have also designed here how potent they are with those bioassays. So the bioassay is there. We know they are toxic as an endocrine disrupting chemical. So you just need more support for that. And of course, a few countries help us. Western countries help us in this respect. So US was one of the first who made a big study for all kind of plastic additives. And you see here, they used a wide range of in vitro toxicity testing. So R is again the male hormone, the AR is the female hormone, and then PPR means is obesity testing, PXR is for early warning. So this is a typical package what you should use to establish if you have safe plastic additives. And you see here it's clear, you can clearly see that bisphenol A on the left side has a very wide color. So you have a lot of mode of actions with this compound and also PFOS and some other of that plastic. So we know there is a wide range of in vitro toxic activities to be expected of that plastic additives. But we know also, you see some of the alternatives here, plastic alternative 1, alternative 7, 11, they have less toxic effects. So we're moving forward to have better alternatives. Now we are involved since about 20 years in different European projects. This was a ChemScreen project. So the European Commission saw already 10 years ago, 15 years ago, we need such bioassay to test, and we have to look for what is the toxicity of that. So you see here many of the phthalates, octaphenol, the phenols, the bisphenol A derivatives, and usually they are activating the female hormone receptor, they are deactivating the male hormone and the progesterone receptor. These are the typical effects for those chemicals. So the data is there. So now we have to look for what are better alternatives. And we are busy with several projects. And what we can see here, if you look at the typical phthalates, we can easily substitute them with decarboxylate, furan-based counterparts. And there we have less toxic side effects from that. So it's really easy to do that with this kind of technologies, and we are busy to do that. Now we look at the most important studies in the last 2 years from Lisa Zimmermann, Andrea Dombrowski, Caroline Völker, Martin Wagner. So they started already 2019 to look at all kind of different bioplastics and plant-based materials. Simon did show a few of them before, so PLA, PBS, starch-based, cellulose-based, bamboo, and biopolyethylene. And this they have tested. They did a 10-day, 40-degree water extraction in that, and then afterwards they oversee 18 they cleaned it or extracted it, and then they put this on the chemical analysis and also on the bioassays. And from that study came out that there were 43 everyday bio-based products, and 67 of the samples induced baseline toxicity, 42 oxidative stress with the IAC, 32 bioassay, and 23 the anti-androgenicity effects, and several were cytotoxic and estrogenic. And before that, yeah, and they also did do chemical analysis. And as Janine said before, in this study here, there were about 41,000 chemical features, with 186 to 21,000 features were present in the individual samples. So 80% of the extract contained more than 1,000 features. Most of them are unique to one sample. They summarized then that 343 are priority compounds, which they need more concern about. We have seen in that sample that cellulose and starch-based materials triggered a strong in vitro toxicity and contained most chemical features. So it's very important that the toxicology and chemical signature is more investigated of those biopolymers, but later I will also show of the other polymers. So the good thing was toxicity was less prevalent and potent in raw materials than in final products. A comparison with conventional plastics indicates that bioplastic and plant-based materials are similar toxic. And the study at the same year was this one here. This was mostly plastic products. The first was bioplastics. The second one now is plastic products. So you see they also come from HDPE, polystyrol, polyethylene, PVC, and so on. And they came from all kinds of different plastic products. And you see here basically the same toxic profile. All nitrates include baseline toxicity. You have 22 oxidative stress responses, 13 anti-androgenicity, and 1 estrogenicity. So these two papers, if you look at both, it seems to be there's not a big difference between bioplastic and plastic. But certainly we need here more investigations like this very excellent studies here from Lisa and the others. And here also the chemical findings look very similar than what I showed before, or what they presented before. And both studies indicate that most plastic chemicals remain unknown. So it seems to be that at the moment, we all know that the chemical analysis focuses on a few chemicals, and we need such bioassays to have a full picture. What is the total toxicity and what are the total impact from the unknown chemicals? And luckily, in the last 20 years, bioassays have improved. We have much more such in vitro toxicology profiling endpoints. So we can look now at more mode of actions. And we need it also because if you look at the diseases, we have more and more diseases where we don't know the reason for it. So there's a clear link from those chemicals to human diseases, I think, in my personal opinion. There was also a study of my colleagues of Orfi in Austria, and so they tested more than 500 samples of different articles, similar than Martin showed, so composite films, PS, polyolefin PET, paperboard, metal cans, and also they showed that more than 70% of all tested had no endocrine activity, so we have about 30% which have endocrine activity, which is similar than the study from Lisa. Less than 25% of all tested were estrogen active. And so I think it's a very similar results than what we have seen in the study before. Now we moved also forward with the PFOS. Now we, last year with Annika, we published this study here, Throwaway Packaging Forever Chemicals. So a European-wide survey of PFAS in disposable food packaging and tableware. And so here was an intensive study of all kind of packaging material from the fast food chain and also from others. And if you look at so here we have done the TOF analysis and also the single container from the PFASs, and we did also use bioassay TTR FITS-T4, which is focusing on the thyroid hormone transport inhibition. And we could see here also in several countries and also in several different packaging material activities, as you can see on the column here. So here certainly is the first indication to do such PFAS testing and TTR activity testing in packaging material. And also with BOD, we looked at the toxic soup, so dioxins in plastic toys. This is a typical example that we have to be really careful with recycling of plastic, because here this is a global survey of many countries, as you can see on the left side, Argentina, Brazil, Cambodia, and so on. The type of consumer products are also very different from toys, hair diadem, cube, hair clips, and so on. This was all black plastic. And usually, if maybe the people would test for PBDEs, but we have seen here that if you recycle PBDEs, then you will have also brominated dioxins. And these compounds are not at all regulated. There are even, I would say, 1-2 laboratories in the world who can test them. And so these are one of the very few studies showing that you have even the recycling chain, you maybe even have at the final end more toxic compounds than before. And you have your chemicals with brominated dioxins, which are not at all regulated somewhere in the world. And also test capacities are not often there. But here the bioassay is a very easy solution for that, to also cover those dangerous chemicals. Now, how is the industry moving forward? As you know, there are now in California and also in Europe, we have more and more that the big multi-international companies should move forward with the recycling quote. Several of those have 5 to 9% now, and they have to move to 25-50% in the next couple of years. So there's of course a concern how they can move the recycling quote up in these companies. And that's why we are working since a long time together with Nestle. And here we wrote a standard operation procedure or a research development recommendation for the chemical and biologic migration screening of metal packaging materials. So this is one of the first approved or approaches that you combine the chemical and the bioassays together to have safer products afterwards. And you can read this SOP. I'm willing to send you this, but I just show you one example here. How would this look like? So usually we are migrating all kinds of plastic materials. In this case, it's coating materials. And then we would, so it's migration for 10 days at 40 degrees, a different kind of chemicals, methanol, ethanol, or whatever is written in the European standards. And then we extract that sample and we put it in a few micro DMSO on the cells. And then we would test for the female hormone activation, the inhibition of the female hormone, the male hormone activation, inhibition. NRF2 is for oxidative stress, PAHs is for PAHs, and cytotoxicity. And yes, you can see here on the left side are a couple of coating materials where you see a lot of activities, while on the right side, you see they are non-active. So this is a typical example. What we think it's very useful to use bioassay, because you can, in a very easy manner, you can very fast screen your plastic and bioplastics and can see if you have in your product chain in the industry also better products, which you should then also more promote. And we are also working with other industrial partners. This is a study from Axel Nobel and us, where we looked at bisphenol A and also their sulfitation products. And this publication here, we were testing the female hormones, the male hormones, the inhibition of the male hormone, and the inhibition of the thyroid hormone. And as you can see on the bottom, the samples 5A, 5B, 5C, these are cellulosic biomass alternatives. These are certainly safer replacements if you look at the bioassay data. So the industry is moving forward to use such bioassays. And also the European Union decided that it's very important to use more of these non-animal alternative testing methods. So we are currently into a bigger European project. One is Risk Hunter, And here the idea is to use such bioassays as screening together with in silico risk assessment to move forward, to have technology in place on a screening level, high throughput out, that we can create new polymers and bio-based polymers. And the other one is Champion. So here's about circular bio-based polymers. Also here we are involved with many partners, and we are involved in the toxicity issues and the safe by design for those materials here. So we will create here novel and sustainable bio-based polymers to be applied in coatings, textiles, home care uses, and structure adjustment. If you want to have more information about it, you can always contact me, or you can look on the webpage Champion-Project European Union. So there you can see more information about these projects. Now, let's come back to my last slide, take home message for bioplastic. As also my colleagues before have shown, we believe that we need safer and sustainable approach for this complex mixture of known and unknown chemicals in plastic and biomass, and we need to use this combined chemical and effect-based biological toxicity screening test. We have done our work, we approved the tests, what can be used for that. We are also very busy with the OECD and ECFAM to have more of this in vitro toxicity profiling accepted. And I showed you a couple examples where we use them for a safe design and green chemistry approach. So we believe that these high throughput bioassays are used decades already for chemical testing. So they are used for screening, as I shown here. But usually we certainly need to apply them much more in the bioplastic and plastic field. And I hope that government and also research institute as well as universities are following these examples from the industrial leaders to have more insights in the truth of plastics and bioplastics from in vitro toxicity profiling. Now, my final slide, if you are more interested in this kind of issues, toxicity of plastics and chemicals, please feel welcome to visit us in Prague on the 13th and 14th September. There's the next Biodetector conference. Here we will cover those issues intensively for 2 days. And now please thank you for your attention, and I'm looking forward to your questions.
Thank you so much, Peter. That was a super insightful presentation. We have some questions from the audience, but yes, I wanted to quickly mention like how some of the things that you mentioned about the risk assessment and how we need to be addressing the mixture of toxicity. That I think was super interesting. Also, you've pointed out how the food contact materials legislation is well overdue. So I think it will be interesting to see in the coming, like some of these studies have been ongoing for more than 10 years now. It seems to be really a slow moving change. So it'd be interesting to see in the coming years. I don't know whether you think maybe some of the PFAS movement, for example, which is really up and coming in the news. Everybody seems to be talking about PFAS recently. I don't know if you think maybe some of these more grassroots movements and communication on this topic will potentially encourage this change in legislation.
We hope so. We hope so. The test systems are developed, but as you mentioned, it's a very slowly process. And I'm very happy to be in this meeting here because it's really about taking the shareholder all together, taking the interested party, and we really have to work together. We have a combined mixture toxicity, but we need also combined forces to move here forward. So we need really NGO, industry, universities, and especially the government who takes more care about that, And please, they really have to open more. What is the industry doing? And then we need also the counterbalance of government also focusing on that. And I really miss that a lot in the global. And we have also an issue that the Western countries are much more active here. So we need also really a global movement to move it forward. So I'm happy to be that you are the United Nations center, local center in Barcelona. And I hope that also the sustainable people help more to use this technology to really go the right direction. We have to know we have about 10,000 PFAS here, and we focus at the moment in the water with 20. in the food with a few. So this will need much longer. So the topic of regrettable substitution must be much more written and taken care, really.
I totally agree. Okay, we're going to take the question from Vincent Lallieu. Thank you for joining us today, Vincent. He says, in addition to bioassays on endocrine toxicity, are they also study on immunotoxicity of plastics and bioplastics? I think you've briefly touched upon that on your slides, but nevertheless.
Yeah, we have also for immunotoxicity NF-kappa-B, but it's not so frequently used. And there are a wide range of bioassays for that. But again, at the moment is a focus on the endocrine disruptor chemicals. And I agree with you, Vincent, we need more of this in vitro toxic profiling. So we need more bioassays because at the moment we don't know really about what are the most suitable immunotox tests. We are using our NF-kappa-B, but yeah, everybody has his own opinion. So we need on a global level also on ISO and OECD to move here forward. But we need really, in my opinion, high throughput out screening tests. Otherwise, we will not move forward with the thousands of questions what we have surrounding the topic of plastic and bioplastic.
Okay, thank you, Peter. We have one last question from Roland Weber. He says, were there some bioplastics in the Zimmermann study, other studies which had no or very low effects and which could be seen as lighthouse products? Are there regulatory frames for using bioassays to test plastics?
Yeah, thank you very much, Roland, for this very important question. Yeah, it's for chemicals, you know, for the bioseeds, there is a framework, but in the plastic world, not at all. So here we are really, it's really important to move forward from the bioseeds guideline for endocrine disrupting chemicals to use this in a read across to the, you know, to cosmetics and also, of course, the plastic additives. At the moment, I think this is mostly in the hand of the industry, but we need here really support from the commissions. So at the moment, there's no regulation. I don't know any regulation using in vitro toxicity testing for bisphenol, let's say for plastic additives or for migration.
Okay. Okay, thank you so much, Peter. We have one more question from Manuel Klar, but I think this is addressed to all speakers, so I'm going to save that for later. So yeah, moving on to our next presentation coming up is Lucas Sattleger. Sorry if I pronounced that incorrectly. He's going to be presenting on the difficulties and potentials of packaging avoidance. If you can please put your presentation up and unmute yourself. Thank you. Lucas Sattleger works as a research scientist in the research unit Energy and Climate Protection in Everyday Life at ISOE, Institute for Social Ecological Research. He is a PhD student in the junior research group PlastX, where he is investigating the role of plastic packaging in the food supply chain. He studied sociology and social and cultural anthropology at the University of Vienna and social and human ecology at IFF Vienna. His research focuses on qualitative methods of social research, sustainable consumption and production, and everyday life practices. So over to you. Thank you, Lucas.
Yes, thank you very much, Kim, for the invitation and introduction. And also thanks for the other speakers for the nice talks. I will now maybe make the picture a bit broader and move away from bioplastic to the general question of how can we reduce the amount of plastic and bioplastic used, as it's not done by just replacing the plastic by bioplastic as you heard. How can I? Yeah. So I will start by a short introduction of my research project and the background and research design. Then I will give you some insights in one of my case studies where it was about packaging functions in the supermarket. So how is everyday work in supermarkets bound to packaging, and how what functions are in packaging more than product safety. And then I will come to conclusions for avoidance and reduction of packaging, and how can we go there. So starting point is the problem of plastic waste, and I was part of a junior research group, Plastics. Actually, Lisa Zimmermann was also part of my research group. Peter mentioned her work before, so I was working in a really interdisciplinary team. We had biologists, chemistry, geography, and I'm a sociologist, as mentioned. And we worked in this broader topic of, how can we reduce plastic waste and more sustainable use of plastics in general. And in this topic, I was focusing on the avoidance of packaging, because packaging is one of the largest fractions of plastic waste, also for bioplastic, as we have heard before. So in Germany, for example, from 27 kilogram per year waste of plastic waste per person, there's 37, so half of it is from packaging. So packaging, if we can reduce packaging, we can reduce the whole waste problem, because it's often littered, it's short-lived, and it's often downcycled, as we already heard from Janine. So it's useful to tackle this packaging problem. And I was interested in how can we go here one step further, because on the one side we have this problem, it's really discussed now, and also in the industry and at the retailers, they know about the problem and they want to change something, but still it's not visible in the numbers, so that the use of plastic and single-use plastic is still not going down. Some countries it's even increasing. Also in Germany, it's still really high. So how does it come? That was my start. And I'm a sociologist, so I also looked at what is research in sociology till now, and mostly focused on consumers. So how is packaging and its function related to consumers and consumption? It somehow changed the way we consume products. It changed also the product itself. So think about convenience food, and also this really food with really long shelf life, that's kind of really bound to packaging. And also, how do we choose products? How it's much more communicated by packaging. But what is not so much in focus before was the question of logistics and work practices. So how is also packaging part of how supermarkets are organized and how work is done there? And that was my interest, and to know more about what is the barriers in the supermarket itself to reduce it. So I was in my dissertation, I'm working on the research question of how is packaging used in everyday work as a kind of tool in practices, and also how it is negotiated there as an ecological problem. So how do you change packaging? How do you discuss it? And from this, I then come to the question of the avoidance and the potentials and difficulties there. And as I said, this was embedded in the bigger research group on sustainable handling of packaging. So we tried then to make recommendations for a sustainable handling from all these disciplines. Yeah, this is my research background in sociology. My theoretical background, I will maybe skip this spoil or just say a few words. I worked with practice theory, so I was really interested in everyday practices as a kind of patterns of behavior which are kind of stable and which are bound to the materiality. So what we do is kind of defined by the things we use, and that was kind of my research practice, to better understand what is the role of technology in this everyday handling there, and how packaging defines how this work and trading is done. So I did ethnographical research, meaning I was really going into the companies, working with them, observing, discussing, interviewing them, and really trying to get an inside view on the use of packaging there. So I started in the first year of a more explorative pre-study to really get an overview on the whole supply chain of food packaging and discuss with researchers, with practitioners in all stages. I did observation in waste treatment, production of packaging, food producers, and then I started to define 2 more concrete case studies where I wanted to do really intense work with partners from the companies, and I was therefore going for 1 month each at the retailer. It was an Austrian supermarket, trying to get insights in their everyday handling of packaging and how they can do something or not. And also I was going at a wholesaler in Germany, where I was part of an innovation process where they tried to avoid this plastic use and reduce it in their company. For example, the foils you see on this little picture where the pallets are wrapped, I was part of avoiding them by reusable strings. So in this second case study, I was more interested in innovation and change and how this change is happening or is not happening. Next to these 2 case studies, I did contrasting also cases in zero waste stores and how they work and what is actually different there. And also in my project, I discussed then these results with stakeholders from all along the life chain to say what can we learn from it actually. So for my first case study, how is packaging used actually in food retailing and why it's used so much? And as I said, I was there in an Austrian franchise supermarket in a rural area, stayed there for 1 month and really participated in the daily work there and tried to understand more about packaging and its use. And coming to the results, I then tried to make an overview of packaging functions which are really important for the supermarket work and the employees there. And I was defining 3 complexes of practices. It's the presentation of products to the consumers. It's the assessment of products in the internal logistics and functionings of the supermarket, and it's the representation of the market and its qualities. So in all of these 3 practices and fields, packaging is really an important part of how this is done. So for example, for the presentation, all this putting products in the shelf, it's really guided by packaging in its shape. So you have this primary packaging, secondary packaging, this different packaging sizes which are optimized for all these tasks, from the lorry to the final employee who puts it in the shelf. So also the shape and size, it guides how these products can be presented, and also the information which is transported via the packaging and its visual communication makes it much easier to present products than if you have just a pure raw product, especially if you think of 10,000 of different products, which is now normal for such supermarkets. And also for the field of product assessment, packaging is a really simple and good indicator for the quality and freshness of the product. So on the one hand, we are best before dates, which are printed, but also it's really easy to see if the packaging is broken or not. And in the freshness sector of vegetables and fruits, it's much more evaluation work and competence needed for doing this. And also for the quantities of stock and flows and for the digitalization of this stock and flow systems in the supermarket and the orders they make, it's really easy to count. You just scan the packaging and see the flows and can digitalize it. But without them, you have to weight the product. It's much harder to synchronize actually physical stocks with stocks in the system. And also for the field of representation, the supermarket as a whole. For example, in supermarket where I was, they always spoke about qualities like Warendruck, like it's product pressure. You see this needless shelves. It's much easier to make this impression with packaging. You can really sort in needless, and also having a wide variety of vegetables which count for a fresh selection. It's organized by packaging, but still here you have somehow an ambivalence in there. So when it comes to freshness, packaging is also not, so this unpacked section actually counts for freshness. So there is also possibility, if we change what is the full and the fresh supermarket, that if this mindset is changing, that actually packaging avoidance gets more attractive for supermarkets as well as consumers. And more on a meta level, then I discussed with another researcher from Berlin, who also did work in this similar topics on different stages actually in the supply chain. We made a kind of heuristics for packaging functions in the supply chain. And these functions actually are really closely related to the product itself. So we defined how packaging changes the way the product is engaging in these practices. So for example, it gives them it gives them a brain for, you can use products to store information. This is done via the barcodes and the digitalization, but also printed information. It's giving a kind of a helping hand for using this product. So processing, cooking, handling is much easier because packaging allows products which are pre-processed and is also giving guidance, how can you use this? So also here it's changing the way products are engaged. And also the body, so the shape of the product is much flexible. If you have packaging, you have this big packaging and different packaging sizes, packaging and packaging, you can really use it flexible for all the stages of the supply chain, have a different kind of packaging adapted to the logistical affordances there. And also it gives them a phase. For example, if you think of brands and etc., packaging is also a phase which is recognizable, which gives trust. I know this and I can trust. So there are these really different functions which somehow stand against avoidance. So we have to think about, if we try to avoid packaging, we also have to think about this broader functions in the social sense, to know why it is so hard for supermarkets to do it just like the small zero waste stores, for example. So coming to my research question, how is packaging actually used in food retailing? It's becoming clear that it's really a diversity of functions in there which go beyond just marketing or technological functions like safety of products. It's giving instructions for the use. It's an infrastructure for the logistics and the digitalization. It's also somehow a collaborating actor doing work which normally has to be done from the people there. So it much more goes beyond a tool. It's much more than a tool. It's really part of this system. And it's, as I said, these functions are really relational. You cannot just look at the packaging, but you always have to look at products, packaging, and practices to change something. So if we just avoid packaging, there come a lot of other problems like food waste, much more work time needed. So you always have to think of these things together. Yeah, that's now leading to my conclusions in direction of potentials and difficulties for avoidance of packaging. So yeah, theoretically, there is this really complexity of packaging in an analytical sense. So it's somehow part of the product, but not, and it's somehow really important and discussed, but somehow in the supermarket, and it's not really the issue. They want to sell products, and packaging is just something which is a side thing, which is not really in focus. So there's not really going resources there to change something on this. And it's also hard if we think on bioplastics and materials. It's really hard to distinguish between the packaging as an object and the material and how we sense it. So bioplastic can look like paper and can actually, so it's really hard to grasp what actually is plastic and what is packaging and what is paper. So there's somehow a complex mixture of things, and we need actually transparency in this system to go a step further. And in this relationship, yeah, we have to think packaging and the goods together, and also different attachments to this materials and products. So what are the actually taking part in these practices, and which functions are in there, and which functions are bound to certain material properties or not. And for the practical conclusions, this means we have to consider, if we think on a reduction, all this diversity of functions, and make somehow context-specific analysis. Can we reduce packaging in this context, and how? And it's not a one-fit-all solution to just avoid packaging or to just go for bioplastics. So we have to be context-specific, and also think of innovation not only on the technological part of the sector, but also in the social side. So social innovations, change in how consumption, how production, how retailing is actually happening, can then make opportunities for technological changes. So it's really, you have to integrate this social and technical, and you have to think on this transformations also as distributed and non-linear in the way that if the policy is changing, if the consumption and the production is changing, then also the supermarket can change. So there's not this one actor actually doing the change, but it has to be from really different sides. And what I've also seen, it's really important to recognize the employees and the ones who actually do the work as also experts of change and what is possible and not. And also another point is the importance of communication and transparency, because this work is part of the whole supply chain. It's important that the supermarket knows what is the packaging actually coming from the producers and also the consumer, that this knowledge and transparency is going along the supply chain, that we can actually make an informed change. Yes. So coming to the difficulties, it's difficult to avoid because it's an integral part of all the system, and there's a lot of trade-offs there, which potentially harm then also the sustainability effect, if we think of food waste, for example. And also it's difficulty that a lot of is happening in the niche, like zero waste stores and these things, but it's somehow hard to go in this bigger mainstream system with a much more standardized. And also the question of marketing and the function of marketing is crucial for this change. But on the other side, if we think on the potentials, avoidance is really a potential because it can actually start everywhere in the supply chain, and it's starting really by the social practices and by the behavior of people. And it's kind of addressing the root of the problem. It's not an end-of-life solution, but really starts by reducing the amount of the cycle, if you think in circular terms. So yeah, that was kind of my sociological conclusion. And then in the research group, we tried to bring this different information together. I can afterwards share our policy brief. We also did a policy brief. It's also in German, actually, but where we tried what can really be outcomes for food packaging and for coming further in avoidance, but also in more sustainable use of plastic and packaging there. So I also did a paper with Lisa Zimmermann where we talked about our view on this question of transparent communication in the use of packaging along the supply chain. Because we both came to this point that everywhere people engage with packaging where they don't really know what it is and what is in there, and also the perceptions of consumers and also sellers of sustainable and not sustainable packaging is really not clear. So there must be more communication and transparency and regulation on this aspect. So, for example, the need for a list of material which are good and which we can use, or chemicals, like this positive list of safe chemicals, and not like it's now you don't know what is in there. And also to securing transparency of these ingredients, that the producer of the packaging must tell you when you buy packaging what is actually in there. And also this need for extended material testing, as Peter actually elaborated before. But also there is need for cultural changes to make this happen. So the collaboration in the supply chain between these different actors must be much more standardized, that this information flows actually can happen. And also the knowledge transfer from science in this more practical field must be improved, that they can really use this knowledge. That was also a big part of our research group, to come in this discussions with practitioners, what kind of scientific knowledge can they really work with. So yeah, our policy brief tackles different aspects. And the first is we have to fundamentally reduce disposable packaging. And this needs a comprehensive reflections on its requirements and functions to do it really context specific. And then we will know avoidance is not possible in every field in a sustainable way. So we have to think of sustainable packaging solutions for this field where we cannot avoid. Yeah, that includes life cycle assessments, for example, or this material tests that we can really compare what is safe and sustainable packaging. And third, we have to think about this innovations as everyday operations in these companies, which are social and technical and include employees and need resources and need time and need testing, that we can like have pilot projects, etc., that this practice-based solutions can be applied. Yes, that was my talk on my dissertation project. Actually, next week I'm doing my dispensio, so I'm kind of now finished in this project, and I'm happy to hear your questions and discussions. Thank you.
Thank you very much, Lucas. That was a really interesting presentation. And I wish you really good luck on tomorrow on this upcoming presentation that you have, defense. So yeah, I think the takeaway message I'm going to take is definitely this, how disposable packaging must be fundamentally reduced. That is something that we work on quite strongly from MedWaves. Reduction and prevention is obviously one of the main focuses of ours. You also talked about the challenges or difficulties and how marketing function prevents the reduction of packaging material. I was wondering whether marketing also prevents the appropriate information display, and in particular with safety concerns, right? I think you also touched on transparency regarding the ingredients. I would go further, not just transparency on the ingredients, but also rating the hazardousness of these ingredients, which is something that for the average consumer, you just see a bunch of numbers and names of chemical compounds, but you might not have any idea as to how this impacts your health or the environment. So what do you think about the marketing function in that regard?
Yeah, I totally agree with you. This is a huge topic in this way. So we kind of, the system now, it's much on concurrence and competition between these actors, and it's like they have their secret of how they make this product, so they cannot share it to others as competition backdrop, kind of. So we more need a culture of collaboration in this way, that it's more attractive to share this information, and this also needs potentially political changes, because yeah, marketing. I think there are these two aspects. One is we have our project and our product, and we don't want others to know it, how we do it, that they make the same. But the other is, yeah, often we don't even know on our own how safe it is, and it's expensive and to make these tests and to communicate it's dangerous. So yeah, there are these different aspects, and so marketing will change when probably the need for this transparency is so strong that it's bad marketing to be not transparent again. Now we are not on this point.
Okay, I'm going to move on to the next question, which was from Roland Weber. Janine, I will take your question. I see you have your hand raised. I will take your question in a bit. Roland Weber says, non-packaging stores or zero waste stores are increasing. How could they be better promoted by government, for the consumer? What do you think?
Yes, thanks. That's true. They are increasing now in Germany. I think we have about 300 of these stores. So it's getting more and more. And also, we see that some of the bigger supermarkets, they recognize them now and try to do things similar. They have this packaging-free shelves kind of things, but still it's a niche and it's hard for them to be more efficient in a bigger scale. So yeah, probably there's need for for more investment in how can we upscale actually these processes. And yeah, I think also the politics should make it more attractive to go for the small scale independent stores in an economic sense. So it's not easy for them to survive economically. Yeah, and also probably there is need for going for a broader group of consumers in the sense of it's now also in a cultural niche in some way, and we need to try to make this. That probably is also an important aspect. Yes.
Maybe
Okay,
I can
thank you,
add
Lucas.
something to this, because this was actually why I raised my hand. I just wanted to add that I think it's very important not to only look at the consumers and try to speak to consumers how to consume better or less packaging. We as BUND definitely demand reuse quotas for all the different sectors. So for business to business, for consumers, business to consumers, and also online trade. I don't think we will get out of the niche for unpackaged or reuse packaging if we don't set regular. This is why we work on this on the EU level, but also on the German level. I don't know if you know, but in Germany we do actually have a reuse quota of 70% for beverages, which is already written in the law. Like it's not fulfilled, but at least we have it, and we fight for. We have many different talks to ministry to at least fulfill the quota in Germany. But then still there would be there's still a lot of other packaging that could also and should also be reused, and it is only resource and energy efficient if the reuse systems are standardized. And this is also a big challenge, because this is a bit what Lucas said before, like these labels and packaging, they also have the function of individualization and also to promote your product. So everybody wants to sell, of course, most products, and the products should be they're individualized. And I think this is really a bad trend that we can only address with standardized reuse pool systems. And yeah, this is still a long way to go, but I think it's very much worth going in that direction.
Thank you, Janine. We're having quite a few reactions from the audience, Peter as well. I'm going to take the last question since we're approaching the end of this webinar. Last question was from Manuel Cla Massanet. He is addressing all of the speakers, so all pay attention. Given the current confusing situation, lack of trust, information, knowing of toxicity of bio-based plastics, and in order to efficiently fight marine litter due to health reasons, etc., should we recommend in general to stop using as much as possible plastics of all types and propose trustable, certified, sustainable alternatives only? Reactions.
I would say Simon had a really good point when he said we should use this bioplastics when it's part of the function that it really makes an effect. when function of biodegradable, for example, is needed, but not as a general solution. So I would say we don't need this one fits all, and we need reduction in a lot of cases, but we can reduce everything, and we probably cannot reuse everything. But yeah, we have to combine this different, and we have to be much stricter what we don't want. That would be my answer.
Anyone else? No? Okay. Well, that brings us to the end of this webinar. Just a quick reminder that any questions, feedback, and comments that you may have can be addressed to the email address that's appearing on screen now. That's kdemiguel@gencat.cat. We will listen carefully to any of your views. So yeah, and also I will invite you to check out the different links that have been shared in the chat. There's some interesting links to the different studies and also the policy brief that Lucas has just shared. Thank you so much to all of the speakers for your time and efforts to make this possible. Also to my team at MedWaves for making this possible. And I'm going to close this with a brief poll. I love polls. So here we're going to launch the last one. Have you learned something new today? That is the first question. I hope you have. Oh, let's see. Launch. It should be coming up now. Have you learned something new today? Yes, or it could have been better. We're also open to that feedback of yours. And would you like to receive any further news about our work? I have to say this poll is slightly slow, but hopefully you should be seeing the results on a screen. Anyway, thank you so much for your participation in this webinar today. I don't know, Magali, if you would like to finish with some words.
Well, this is a complex issue to summarize. No, there is no perfect magic solution, unfortunately. So I think the solution, they need to really take into account also the local context. So it's not that everything can be applied everywhere. So there is the socioeconomic context, and well, everything is interlinked. No, this is what is complicated, and there are still well, the industry is also moving very fast, and then well, other stakeholders need more time now to also study and understand what would be the impact. So we need to, well, really have a multi-stakeholder approach and understand the topic before taking well, good decision that could really have an impact, no? And having well, try to avoid for example, rebound effects that what we can see now in some of the solutions that are adopted. So, well, I will stop here. Well, stay tuned, and then thank you so much for your active participation and the great contribution from the speakers today. And thank you, Kim, also for the great work behind the webinar. This is also, well, a lot of involvement. Yeah.
Thank you so much, Magali. Okay, well, I wish you a good end to the day and a lovely weekend. I hope to see you soon. Goodbye.
Thank you. Bye.
Bye-bye.
Goodbye. Thanks for all.
Goodbye. Thank you.
Bye.